So welcome to our fifth instalment of AS Trigonometry. In this video what we're going to do is we're going to go through and introduce the trig identities that you need to learn and also know how to derive. So there are some trig identities or trig rules that you need to learn to help you answer some solving trig equations, and this usually lies when you've got a mixture of trig ratios in your equations, when you've got a mixture of sines, tans and coses in your ratio. And also with trig proof questions, so when you're asked to prove that one side is equal to another, and it'll usually generally involve a mixture of trig ratios, and this is where it comes into play. So to start off with, what we're going to do is we're going to start off with a right angle triangle where the sides are going to be labelled x, y and z with an angle of theta. So to start off with, what I'm going to do, as this is a right angle triangle and it's involving trig, I'm going to start by labelling my triangle. So this is going to be my z is going to be my hypotenuse, y is going to be my opposite, and x is going to be my adjacent. So from this, what I'm now going to do is, using SOHCAHTOA, or however you're used to remembering the trig ratios, I'm going to start by writing what they all are. So for this, what we've got is we've got that tan theta is opposite over adjacent, which is y over x. Sine theta is going to be equal to opposite. Oh, I've gone for the opposite. It should write the letters. So our opposite in this case is y over the hypotenuse, which is z, and cos theta, which is equal to adjacent over hypotenuse, so that's going to be x over z. Now if we then start with, let's say, what sine theta over cos theta. Now all I'm going to do is I'm going to substitute these expressions. So we'll just get a different colour pen, it's taking its time. So what I'm going to do is I'm going to substitute this sine theta equals y over z and cos theta for x over z, and substituting it into this, what I get is I'm going to get y over z over x over z. Now if I just quickly take that out of context of what that actually represents to simplify this, then this is y over z divided by x over z, and if you remember the rules of dividing with fractions, we flip the second fraction and it then turns into a times, and as you can see from there my z's will cancel, and lo and behold what this will then turn into is y over x. And if you can see from this proof here of tan theta equals y equals z, then that's going to equal tan theta. So from this, our first identity that we need to learn and need to remember is, and forget a different colour pen, let's go for dark blue. So here my first trig identity that I need to learn is that tan theta is equal to sine theta over cos theta. And I'm just going to put that in a bubble and in a square even. And the key thing to remember in regards to this is something that you need to learn, so you must learn. So moving on to our second identity that we need to learn, and so what I've done here is I've just written down what those trig ratios are in relation to this triangle that we've got above. So to start off with, what I'm going to do is, as I've got a right angle triangle, I'm going to see what we get when we use Pythagoras' theorem. So from this we know that we're going to have x squared plus y squared equals z squared. Now from this, what I'm now going to do is, if I was to divide everything by z squared, then what I'm going to end up with, if I get a different colour pen, let's go for blue. So if I divide everything by z, I get x squared over z squared plus y squared over z squared and z squared over z squared. Now from this, all I'm going to do now is rewrite this in a different way. So if you remember what we do with regards to indices, I can write this as x over z squared, so I can take the square out. I can write this as y over z squared, and z squared over z squared is just going to equal 1. Now from this, if I now incorporate what these all mean from here, then from that what I end up with is, let's go for orange. So from this, if I convert this bracket of x over z, now x over z is cos, so I can write that as cos squared plus, and now y over z, looking at my trig ratio, is equal to sine squared, so sine theta squared equals 1. And if you remember the video from when we're doing from trig equations, that we can, what this actually means is we write this more formally as cos squared theta plus sine squared theta. And the reason why we write it in this format again is so that we're differentiating between sine theta squared and sine theta squared. Now it sounds different, but basically sine theta squared is not equal to sine theta squared. In this example here, the theta is being squared, and in this example here, the sine theta is being squared. So they are two completely different things. So returning back to our trig identity, our second trig identity we need to learn is just this. So here what we've got is our second identity is that cos squared theta plus sine squared theta is equal to 1. Now, being forward thinking, what you also need to learn, as well as this particular trig identity, is the sort of manipulation of this. So using this, we know that cos squared theta is going to be equal to 1 minus sine squared theta, which is just from doing a bit of rearranging, and also that sine squared theta is equal to 1 minus cos squared theta. And that also is something that you need to learn. So although they say there are two trig identities, well, learning the second trig identity in this format is equally as important.